Good morning, everybody. Well, this is the third talk about WebRTC, but I'm going to try to give you a different, a more grammatical view of WebRTC technology. Okay, well, just a quick presentation. We are based in Spain. Our main activities SIP integration between operators and companies. And 3 years ago, more or less, we started to work in WebRTC. I think many of you know Victor Pascual. He joined us almost 1 year ago, and he's involved in IETF activities. He's co-author of the SIP over WebSocket RFC. Okay, and before he joined the company, we started SIP over WebSocket stack, WebRTC. And we are also working with other organizations like the SIP Forum and ATIS DSI. I will explain later what orca.js is. Okay. Well, right now we are running around 30 proofs of concept, integrating WebRTC and different operators and call center companies. Okay, and we are learning a lot of things from them. We have our own demo platform, and we use Kamailio and FreeSwitch to implement it. Okay, it works very well. But we also have to work with proprietary solutions. Okay. And, well, as you know, there is any signaling protocol for WebRTC. Okay, it's up to the developer to use any protocol to make to get things working. Okay, so what happened? That there are a lot of signaling protocols. Some of them are standard or almost de facto standard, and other are proprietary. Okay. Well, there are like two types of signaling protocols. The first one is SIP over WebSocket. Okay. This is VoIP friendly. Okay. Many of us could speak SIP to each other in this room, but WebRTC is not for VoIP. Okay, WebRTC is for web. It's to develop web applications. So we understand perfectly all the message, but that it doesn't happen. Web developers doesn't. Okay, I don't know if you know what trickle-ice is. Okay, one of the problems of WebRTC is the delay to establish a session, because you have to exchange a lot of ICE candidates. And using SIP, well, there are solutions to implement trickle-ice in SIP, but normally you have to gather all the candidates, you send the invite, and then the other side gets your candidates, create their own candidates, and the other side send you the candidates in the 200 OK. Okay. It takes a lot of time. So trickle-ice allows you to exchange the ICE candidates as soon as you get them. Okay. It's possible to implement that in SIP, but you have to exchange message before the dialogue is established. Okay. And well, the good thing of SIP over WebSocket is when you have to integrate your WebRTC solution with the IMS score of an operator, whatever, or any SIP network, you can change things very easily in the stack. Okay, there are things that you can change in Kamailio, or the solution you use to interconnect to the SIP network, but there are other things that you can change directly in the stack, and it's very easy to adapt. Okay, and it works with all the open source solutions, well, like Asterisk, Kamailio, FreeSwitch. Okay, there are other alternatives like XMPP over WebSocket. There are open source libraries implementing it. Well, I'm not going to discuss what's the best solution, because the important is that is to get things working well and always. Okay. Then there are other solutions for signaling. One of the most used is JSON over WebSocket. Okay, this is a generic strategy. It's not a fixed protocol, because in JSON you can send whatever you want. Okay. One of the advantages of using zip is that you don't have to reinvent the wheel. Okay, if you want to make a code transfer, you know how to do it. Okay, you don't have to invent JSON message to do it. But it's also possible. Okay, because we normally see it as web developers, but for a web developer, it's not intuitive. Okay, so and it's easier to implement trickleize, because you just have to send another message to the other side. Okay, there are other solutions like REST API. Well, it's just another alternative, but you need to implement a strategy to get the events from the other side. Okay, if you want to receive a code, you have to implement a long polling strategy or using WebSocket. This is what normally many vendors use APIs they already have to implement WebRTC features. And other strategy is to use data channel for signaling. Well, it has less latency because the messages go peer-to-peer. But anyway, you need some signaling to create that data channel. So it's not, well, there are alternatives which works, but it's not, well, it's like incomplete solutions in some cases. Okay, so there are a lot of alternatives, but we found some problems with that. Okay, because if you implement a web application which works perfectly with one signaling protocol, it normally doesn't work with another one. Okay, so you have to spend a lot of time and money in adapting your application. And when you deal with the web managers of the websites of the companies and operators, they don't care about the signaling. The signaling and the WebRTC part is expected to work. Okay, they need a way to integrate it easily with their web applications. And well, all the signaling stacks for WebRTC offer expose an API that you use, but there are different APIs, and the interaction between the API and the WebRTC API from the browser is different in each case. So what is the solution? Okay, you can have different signaling protocols on the lower level, but you can expose a common API. So if you develop one application which works perfectly with a solution for any vendor, you can use a zip stack which exposes those that standard API, and you can get it working with Kamailio, for example. Okay. So the name of that project is orca.js. It's in GitHub. I will show the URL later. So the idea is to abstract the signaling part and the interaction with the WebRTC API of the browser to the web developer. Okay. So you only have to learn how to use orca.js, and then you will be able to use any different signaling solution. And we found it very, very useful. Okay, so this is an example of orca.js code. Okay, you can create a session. Well, this is this token parameter is well, orca.js defines that parameter to be able to implement authentication mechanism. Okay, if your signaling protocol doesn't use any kind of token, well, you can send whatever. It can be a dummy parameter. Okay. So the idea is to expose a common API. You create your web application once, and you can use it with any gateway. Okay. Well, this is an example of application we developed. It's a Gmail connector. It breaks a little bit the philosophy behind WebRTC because you have to install a Chrome extension, but this Chrome extension detects that you are in your Gmail page, and it gets your identity. We get your VoIP identity linked to your Gmail identity, and then you can start making and receiving calls. Okay, so using Orca.js, we can use this application with Kamailio and with any other vendor solution. Okay. Well, and now this is another example of application you can create with WebRTC. It's a click-to-call solution, and I'm going to explain a little bit what things you have to take into consideration when you implement a click-to-call solution using Kamailio. Okay, this is another example of application you should be able to use with many WebRTC gateways without taking care about the signaling protocol. Well, for click-to-call application, it's very important to gather contextual information. Okay. Well, of course, you have to take into consideration legal and ethical points when you get that information. But okay, normally you can send, for example, the location and also the URL from which you are clicking the click-to-call button. And it's also very important to take into account that you can suffer denial of service attacks very easily. Okay, because you are when you deploy a SIP system, okay, you have your subscribers, you deliver a soft phone or a hard phone to them, and you can suffer a lot of attacks as well, but the environment is a little bit more controlled. But in the web, everything is open. Everybody can access your application, so you have to take care about denial of service attacks and also fraud attacks, because well, it's very easy to check your JavaScript code and to try to send the code to a different destination. Okay, it's normally it shouldn't happen, but it's possible. It's possible to happen. Okay, and also it's important to limit the whole number of the calls you are sending to the SIP network, because this way you minimize the impact of distributed denial of service attacks. Okay, and also you avoid to collapse the call center with valid traffic, with traffic from users who want to use your service. Okay, but the call center can handle such amount of calls. Okay, well, what we did with Kamailio very easily. Okay, we modified a little bit our SIP stack to send some custom headers. Okay, so you can set the geographical location of the browser. There is an API in the browser which gives you your coordinates, and also well, you can send the URL. Okay, well, it's important to. I think Peter saw something about that yesterday, because well, you shouldn't allow to a user from the same location to make a lot of calls. So you have to get IP and port and to store them in a hash table or Redis or whatever to to prevent it from making a lot of calls in a short time. Okay. This way you can store all this information directly in Kamailio CDRs, and so that you can offer it to the to the call center, to the operator, so that they can process that information, and that information can be processed directly by the agent who is answering the call, or later by the business intelligence processes to analyze all the data. Okay, so and this is the architecture we are using for that. This can be a Kamailio, of course. The media relay. Well, right now there are several open source alternatives to implement that. We are developing a web application controller, WebRTC application controller. Well, to handle a lot of things which are not to be able to implement WebRTC application to get gather stats and logs. Of course, this part is not essential, but you always need something to do that kind of things. And in the last release of the WebRTC, the approach for IMS, released by the 3GPP, they are considering to define a reference point between the PCSEF and I think the name the 3GPP uses for this is WSF or something like that, so that you can get you can implement authentication strategies. Okay, in a click-to-call application, the authentication strategy is a little bit different because the user is anonymous. But well, this you can use this architecture to authenticate users in a city network, for example. Yes, and well, that's all. So if you want to make any question, you are welcome.
Thank you. Are there any questions? I have a question from, can you say something about the availability of the different tools you provide? Are they open source or is there proprietary in-house?
Yeah. Well, the WebRTC stack is open source, of course. It's in GitHub. Orca.js is also in GitHub. You can go there, you can check it, you can propose changes. And regarding the WebRTC application server, I think we have not released anything yet, but I think we released some parts of it soon. It's developing Node.js, so it's very it's easy to change.
Some more questions? Don't think so? Okay, thank you again.
Thank you.